Okay, here we are for lesson 14, checking for identical triangles. This is part 2 of a two-part lesson. So in contrast to lesson 13, where we had to examine pairs of distinct triangles, lesson 14 presents diagrams of triangles so that a relationship exists between the triangles due to the way they are positioned. So the opening we're going to do is in your journal. Go ahead and take a look, scan the figures in the next several problems on your lesson worksheet. How are these diagrams different from the diagrams in lesson 13? Alright, you should be done looking at those figures on your lesson worksheet. You would notice that the triangles seem to be joined instead of being separated. Does this change the way you figure out if a condition exists that determines whether the triangles are identical? Well, you have to check the connection between the two triangles and determine if it shows whether the two parts between the triangles are equal in measure. In each of the following problems, determine whether the triangles are identical, not identical, or not necessarily identical. Justify your reasoning. If the relationship between the two triangles yields information that establishes a condition, describe the information. If the triangles are identical, write a triangle correspondence that matches the sides and angles. So you're going to need your list of triangle conditions to refer to from your previous lesson. So let's take a look at example 1. So here we have a figure of two triangles, but notice that they are connected. They share the same side line segment WY. We also note that the sides WX is equal to ZY, and we also notice that through the marks ZW is equal to XY. So what is the relationship between the two triangles below? Well, the triangles share a common side. Imagine that triangle WXY and triangle WZY were pulled apart and separated. Sketch the triangles separately. Based on how they were joined, what kind of tick mark should be added to each triangle? Line segment WY is a common side. Since it belongs to each triangle, we should put a triple tick mark on line segment WY to indicate that it is part of equal measure in both triangles. So this is what we mean by separating them, and you're going to need to do this throughout the rest of the lesson. So you take the one single figure and you split it up into two separate figures, making sure that you label each angle and vertice and also indicating which line segments are equal in measure. So are these triangles identical, and how do you know? Well, the triangles are identical by the three sides condition. The correspondence that matches the three equal pairs of sides is triangle WXY corresponds to triangle YZW. Alright, exercises 1 and 2. Complete these on your lesson worksheet. Continue the video to check your answers. As shown previously, consider modeling the process of sketching the triangles as unattached to one another. Alright, you should be done with exercises 1 and 2. So go ahead and check your answers. They did not go ahead and draw these as separate. However, you should have separate models so that you can identify which line segments are shared and are equal. If you have any questions, please make a note and bring them to class the next day. Alright, let's continue. So example 2. Are the triangles identical? Justify your reasoning. Notice that they are only attached by a common vertex of O. So what is the relationship between the two triangles below? The triangle is positioned so that there is a pair of vertical angles. Angle AOC is identical to angle BOD in the diagram. The triangles are identical by the two sides and the included angle condition. The correspondence, triangle AOC, corresponds with triangle BOD, matches the two equal pairs of sides and a pair of equal angles. Namely, angle AOC is equal to angle BOD, which we know to be equal in measurement because they are vertical angles. Alright, exercises 3 and 4. Complete them on your lesson worksheet. Continue the video to check your answers. As shown previously, consider modeling the process of sketching the triangles as unattached to one another. Alright, you should be done with exercises 3 and 4. Go ahead and check your answers, and if you have any questions, make a note so you can bring them to the next class. Alright, let's take a look at exercises 5 through 8. Go ahead and complete these. However, continue the video after each one to check your answers. As shown previously, consider modeling the process of sketching the triangles as unattached to one another. Alright, you should be done with exercise 8. Here is the answer. Check your answer and then proceed to exercise 6. Alright, you should be done with exercise 6. Here is the answer. Check it and then proceed to exercise 7. Alright, you should be done with exercise 7. And here is exercise 7. For exercise 8, you need to create your own label diagram, which you will share in class. Alright, so in closing, in deciding whether two triangles are identical, examine the structure of the diagram of the two triangles to look for a relationship that might reveal information about corresponding parts of the triangles. This information may determine whether the parts of a triangle satisfy a particular condition, which might determine whether the triangles are identical. Alright, we'll see you in class.